Andy. So we're gonna derive the Lagrange equation here. So we have the distance between 2 points here. We're gonna find the fastest way between it. We're gonna assume some kind of y of x. We're gonna y of alpha of x. We're gonna change alpha by this little iteration omega, right? So it's gonna kind of like that. We can't call it b of x here. First, we'll do the integral with we're gonna have a position, a slope. We're gonna have the starting with the position, slope, and how far. We're going to call this all j of alpha. So we get this whole little thing. Right, we have alpha of x, y prime alpha of x. That's supposed to be y there. Sorry, this is all f. Remember, we want that to be 0. So we plug it in and we start looking at it. All right out there. So you have our f of x with this little iteration here. Right, we're going to integrate through. We're here by the integration prime because it's all primed. You know, the chain rule here, so we have this equation down there, which let me zoom in a little bit if I can. There we go. So we have x1, x2, df dy of eta plus df dy prime, eta prime, the x, because you know this becomes 0 over there. F of alpha is just 0. So integrate by parts, we can get rid of this problematic eta prime, right? We identified that as a problem. So we have uv dv du, rv du. This becomes 0, and I can't. Oh, I can move this over a little bit. Okay, so zoom out a little bit here so you can kind of see it all again. Then we're gonna bring that down here and put it back in because that was just for the second part, right? That was just to get rid of the prime. So we still have this part down there plus this part, which we know to be that right there. I'm going to zoom on that specifically, and I'm going to allow fun with the zooming. That equals 0, as we know. So then we factor out the eta, and we get our Euler Lagrange equation. Now, normally when we do this, we actually use t's instead of x's, but it's really all kind of the same thing. It's all just with respect to t. So yeah. I'd argue it's the most useful thing we've done so far in this course.